Today's lecture is pretty free form. There's like not much structure to it. I'm just going to go over a bunch of stuff that I think you should know. It's by no means like the final word on SFML or ImGui or anything like that. I'm literally just like bringing up the tutorials and reading which parts of it I think you should know. But it is a great idea to like read part of that documentation, because there may be things that you wouldn't have found if you were searching for a specific thing. But as you read the tutorial, you're like, oh, I may actually use that later. Or later on when you have a question, you may have seen something in the tutorial that is related to that, but may not have come up with a search. So it's a very easy tutorial to read, as you'll see when I go over maybe like 10% of it today, but it is really great. Also, I had someone email me and ask why I didn't post the slides for assignment 1, and that's a good question, but basically there was no PDF for that lecture. I just opened up the README file and read through the README file and the environment setup. So if there is no actual PowerPoint slides for a lecture, there is no PDF to be produced, and so that's why it's not posted there. So typically for an assignment, there won't be any lecture slides posted because of that. I do have a few slides today, so I will be posting them on this one. And just keep in mind that, you know, the assignment, you've got, what, 8-9 days left to work on it, so make sure you're getting started on that. And please feel free to come by the office hours. I posted today that the office hours are basically right after class, but if the door is closed, I'll open it at 5. Sometimes I just got to put my stuff away or whatever before I start the office hours. So you don't need to make an appointment for office hours. Just come by, and if there's a line, just wait in the line, and I'll be there until all the questions have been asked and answered. Okay, so one other question that I had from several different people, which I posted on Brightspace about, but I'll mention it here again, was that in their Visual or VS Code, they had some errors. So for example, this, not print isn't what I released to you, but like include SFML graphics, that was underlined, and it said it couldn't find the library or something like that. And subsequently, because that one wasn't found, down here it said, hey, SF render window, like this line had an error on it. That's not actually an error with the code. That's just VS Code's linter or IntelliSense not being able to find your libraries. And so there's some sequence of steps that you can take to set that up. I'm not sure, because my VS Code has been installed for so long, exactly which thing that you have to do. But I will show you really quickly, if I zoom back out here. If I go to, I think this is extensions, I only have 7 extensions installed, so I'll just scroll through them. So I have the C++ extension, I have C/C++ extension pack, C/C++ themes, CMake, CMake tools, and make. And so I think what happens on my machine, the reason why those errors don't come up, is because one of those make packages, or the C++ package, sees that there's a Makefile, and the Makefile actually shows like where those libraries are. And so since it's included in the Makefile, then somehow this knows where it is. So yeah. Really all you need to be concerned with, even though it is kind of annoying to have your IDE or your editor tell you there's an error, is, hey, was there an error when I compiled the program or when I tried to run the program? That's the big error. This would just be more of like an annoying little thing that you have to fix somehow with the VS Code settings. But since I'm not like enforcing VS Code, I'm not going to spend a bunch of time like saying how to set that up. You can use all the ChatGPT in the world to set up your IDE. That's fine. I don't mind using AI for that kind of stuff. But what I am going to do first is just go through the Makefile, not in complete detail, but I just wanted to show you like what it's all about, exactly what's going on here, so that you should know the lower level details of what's going on. And for those of you not using the Makefile, just realize that the Windows, so the Microsoft Visual C++ compiler, so it's MSVC for short, the compiler for Visual Studio has a project file which operates similar to how this Makefile would operate. It contains all the compiler flags, all the different warnings you want turned off, all where the libraries are and stuff. That's all contained in the Visual Studio file. But the reason I'm not going over that is because it's this like huge mess of XML that's like kind of annoying to read, but it's there and it just works. So in the Makefile, we start up here, and Makefiles can look so incredibly different from machine to machine. I just want to make sure that this is recording before I go any further. Yeah, it is. Okay. So different people have different syntax and all sorts of rules for their Makefiles, how they like to write them, how they like to declare targets and stuff. Some people would probably hate my Makefile. Some people might really like my Makefile. I'm not saying this is how it's done. I'm just explaining like what it does and what the variables in the one that you've been given me. So the first one up here is CXX, and that's just a convention for listing the compiler. And so the compiler here is G++, that's the GNU C++ compiler. If you switch this out for Clang++, I'm sure it would also work. So we're just using that one by default. Output here, that variable is used down here to denote what the actual output file is. So the executable in Mac and in Linux doesn't have a .exe at the end of it, so we've just called this SFML gain. So once you compile it, it will produce that executable SFML gain, change the permissions of that file so it is executable, and then you can run that as the executable that you output. OS here is, that is the operating system that you're using, because I've just made a single Makefile that works for both Linux and for Mac. And the way it knows which operating system you are on, and now I'm sure with modern CMake or Makefiles that there's probably a better way to do this. But if I just come over here to my terminal, if I type uname, then it says Darwin. And so that the Mac OS X, that's what comes up. And so the Makefile runs that script internally, gets that string, and it knows that you're using Mac if that's the case. Also, you have this source directory variable, and the source directory is what we say to include down here when we actually come to the compiler flags. So inside our code, if I go over to main.cpp, whenever you include something, the convention for using a sort of system library, meaning that like it's a C++ library or it's some library that you have installed on the system, is to use these brackets here at the end. So include print or include memory, include fstream, include SFML graphics. Those don't live in the source directory, but it's assumed that your compiler will somehow know where those libraries are. So on Linux, you know, you've got like user include, user lib, all these, or maybe user local include, whatever your Linux distro does. And so it will just like know where these are, so you don't need to actually specify where they are. But, for example, these two files here, imgui.h and imgui-sfml.h, those are not actually installed on your system. I have given them to you. So in order for the compiler to know, okay, I'm including imgui.h in these quotes instead of parentheses. Now, the difference between quotes and parentheses is not a big deal. But down here, at some point in the Makefile, I have to actually say, okay, include that directory. So the way it knows where to get that file from is I've told the compiler with the -I flag to look in these directories for things that I'm compiling and things that I am including. And so that's how that works. So I've included everything in the source directory, and I've included everything in the ImGui directory that is within the source directory. And so that's how we know that we can include those things. So in my version here, if I come over here and I type make run, then that will run what is in my source directory. But if I go back here and I type, as my source directory, I type source solution. Oh my God, I can't type today. And then I come back over here and I make clean and make run. Then I've basically said, instead of looking in the source directory, I'm looking in the source_solution directory, and then I get the solution, right? So if you wanted to, for example, to be able to compare a working version of your assignment with the version that I gave you initially, you could create a separate directory called source student or source current or something like that, put all the files in there and work on them and switch back and forth just by editing the Makefile. So that's what I do when I'm developing the solutions for these, because it's pretty easy to do. So that's what that directory is. Then if we come down here, oh, by the way, put up a hand, ask questions anytime. You don't need to wait. I may not be able to answer very in detailed Makefile questions though. So here now we have the different options for both Linux and Mac. So everything that's not in these two if statements are basically global and work for any operating system, but inside these two statements are just a little bit different. Actually, I could have included I think the CXX flags are the same, so I could have made that outside this if statement to be a little bit less verbose. So let's just look at the Linux one. CXX flags, those are the compiler flags. So if CXX was the compiler, then these are the flags. So we're turning on optimization level 3, which makes the code just run a bit faster. We are using the C++23 standard, which means that things like standard tuple, which we'll use later for our components, and standard print, if you're not using Linux, will work out of the box with C++23. If we removed standard equals C++23, then the compiler, for some reason, defaults to like the old original version of C++ and doesn't include any of these new features, right? Why they don't just default to the latest version, I'm not sure, but maybe it's a backwards compatibility thing. The next two flags that I have are -w no. And so that's the way of saying don't warn me about these particular warnings. So with any compiler, there will be two types of messages that you might get out while it's compiling. One is an error. So an error is like a syntax error, right? Or I can't find this file. It cannot continue any further. That's why it's an error. So error messages stop the compilation progress. And warnings will not stop the compilation progress, but they'll tell you, hey, this is something that is probably bad, right? But it can still compile the program. So one of the things that I've done is in your skeleton code that I've given you, sometimes there'll be some variables there that I've set up just to help you that don't actually do anything. So it's like string name equals Dave, but then I don't use that thing. I just showed you how to set up a string. So this says the compiler, if you don't use a variable, it will warn you, hey, there's an unused variable here, because that's inefficient. It shouldn't have them in the program. But I've just turned that off because I didn't want a bunch of warnings popping up for unused variables that I give you in the skeleton code. And over here, this is deprecated declarations. Say that 3 times fast. But this one, at some point in the course, I realized that there was something that SFML was including that had to do with OpenGL that was like some deprecated thing that just had to happen in order for it to work. And I said, okay, I don't want to have to explain this, so I'll just put that there. So this is how you would say to your compiler, hey, I don't want any warnings. Now in Visual Studio, I've done the same thing, but in Visual Studio, you right-click the project file, you go into C++, and then under all options, there'll be a little field there where you can type in specific error codes. And then that's what I've done in the Visual Studio project file. Includes, so again, these variable names don't matter so much. I could have called this A and could have called this B and could have called this C, but it's nice to give variable names something that means something, right? So here are the things that I want to include in this compilation. These are the directories. Yep, I'll get to your question in just a second. And then down here, LD, that is the linker. And so this is the linking step of the executable, and this says, hey, and I'm actually not sure, I don't think O3 actually does anything at the linking step. It might, so I just left it there. And these are the libraries, the shared library files. They're almost like DLLs from Windows. So if you've ever used DLLs in Windows, like it's some other person's code that it has to call in order to run your thing. This is how these are included or linked into your program to form the final executable. So in Windows, this is done by the linking. If you right-click the project, go to linker, you'll see all the different .lib files instead of these files that are included here. And at the end here is telling it to link OpenGL as well, because SFML is based on top of OpenGL. Did you have a question?
I was just asking, in the intro to C++ video, you said that we have to use the 17, C++ 17, and you're using 22.
Yeah, the video is just several years old. Yeah, and so back then we were, using whatever was current. And so the question, just repeating it for the video, is why in the other video did I use C++ 17? It's just because I'm trying to keep up to date. And it's actually pretty likely that we won't be using any features that are have been introduced in 23. I just want to make sure that that's up to standard. And in fact, there is a difference between the Windows compiler and the GNU compiler, which I was surprised about because I would have thought that the Windows compiler would have sort of been behind the Linux compiler, but it's actually the opposite, where things like standard print aren't in the C++23 standard for G++, but it is for MSVC. So that's a little bit strange. Okay, so that's the Linux version. And now down here, because the Mac works a little bit differently with how the compiler reads like where the libraries are installed and stuff, really the only difference here is that there's an extra variable that actually explicitly points out where this thing is. If you guys wouldn't mind, stop talking, and this is really distracting while I'm doing this. So this SFML directory, that is where SFML is installed, and within that there's going to be an include directory, and that's where all the header files are that you include, and so that's where that extra part comes from. So that's not there in the Linux version because it doesn't need it, but as far as I can tell, the Mac one does. And the only difference, which when I got this Mac and I started supporting Mac for this course, the only real annoying thing I had to figure out is that instead of -lgl, you have to type in -framework space OpenGL, right? So that's one of those things that ChatGPT really helps with, is just someone would just have to tell you that, right? And it was like 2 hours of Google searching a few years ago versus just typing it into some AI system now to tell you that. Now, I'm not going to get into everything that a Makefile can do. That would be a very long talk that I don't completely understand myself. But basically, the only things we have left to do are declare where all of our source files are. So this is saying, look into the source directory, and it's got this weird syntax with $signs and wildcards and all this kind of stuff. It's ancient, but it still works. So look in the source directory for anything called .cpp. And look in the source directory /ImGui for anything called .cpp. And those will be compiled into object files, and you're going to name those object files. So anything that was called .cpp, you're going to take that file, compile it, and name it .o. And then down here, this is just some dependency files. I won't get into that. It's so it knows what to recompile. And then down here, at some point, so the linker is going to take all of those object files and link them together with your linker flags, telling it where all the SFML stuff is, to take the output file and then put it in the bin directory. And so that's what that does. So down here, we can also specify other targets for the Makefile. And those targets can actually, they don't have to be compilation-based things. They could actually just be commands that are run in the shell. And so luckily, all these commands work fine both in OS X and in Linux. So if you type make clean, the way that works is it literally just rm-rfs all the files that we could have produced during this process. So all the object files, all the dependency files, and all the output files that we created, it's just a literal rm command. And then run will take the output file that we've created, it will cd into the bin directory, and run the output the output executable, and then once that's done, it will cd back out of the bin directory into the directory that you were just in. So I didn't have this there last year, and I realized after the first assignment, after helping people, they came to my office and I saw that they were typing make, then cd bin, then /SFML game, and so this is just a shortcut for all of that to help speed up your process. Okay, so that's as much as I want to get into the Makefiles. But I think I mentioned this last time, but I just want to say it again, if not, where I am in, okay, so I'm in the A1 root directory, and if I type make, oh, everything's up to date. Oh yeah, so this is also one of the good things about a Makefile, is that if I make clean, so I've deleted everything, now I'll type make, and you'll see that because I told it to build everything inside the ImGui directory, It's going through the ImGui directory and it's building all of those CPP files. And then at the very end, it builds the main.cpp, right? But because all you're changing in your program, if I just write a comment here, all you're ever changing is the main.cpp file. So one of the main benefits to using a build system like this, and this will also happen in Visual Studio, is if I type make again, then make looks up all the modification dates, and it says only recompile any of the files that have been modified since the last modification date of the executable. So if there's a .o file that's the same time or newer than the executable, then I know I don't have to recompile that. But if I have changed any of those ImGui things, then it will recompile that as well. And so I'll just clean that again. And of course, there's also the make-j whatever, and that's the number of jobs. And I think if you just type make-j, yeah, so make-j will just look at your system, figure out how many threads it should do it in parallel. So make-j run is probably what you should, or make run-j, I think that's it. Make run-j. Yeah, so that's probably what you should be typing in order to be as fast as possible. All right, any questions about any of that Makefile stuff, or? Yep.
You'd be able to add that -j into the Makefile, right?
Probably. I didn't, because the Makefile is supposed to specify the parameters for the compilation. And then the -j is a parameter for make, right? So I didn't want to include it in the Makefile. So just like you can have that one command, then just hit up every time you want to recompile. So I wouldn't recommend necessarily putting that in the Makefile. But if you have something like CMake, which is a bigger build system with a lot more options, you would probably have the make-j or -j flags in the CMake file rather than in the Makefile. But I'm not a CMake expert, so I won't say anything that might not be true. All right, so I have a few slides here, and the slides are there's a little bit of stuff on ImGui, and then I've linked to some stuff on a website that I'll look at. Here we go. All right, so let me get my laser pointer out. Okay. So SFML, as we've discussed, it's called the Simple and Fast Multimedia Library. And the reason I chose SFML, so there's also a really popular library that does the same sort of things as SFML called SDL. And SDL, I think, just released version 3, which is probably really great. But I used SDL2 a lot, and I just found it a little bit too verbose for this course. It can do all of the same things and more. I'm not saying one is better or worse, but I want you to be able to like read in a PNG file and draw it to the screen in 2 lines of code. And that's what SFML is really good for. SDL also supports like 3D stuff, and SFML is only 2D. And that's what I want for this course. It's multi-platform and multi-language. So if you click this link in the PDF, it will take you to a bunch of bindings for like Python or Java or other programming languages that can use SFML, but of course we're just using the native C++ for this course. And basically SFML, like I say that this course is like game engine programming from scratch, but from scratch always there's some caveat with that, right? Are we building the operating system? Are we building the hardware? Well, we're going to stop at the level of SFML, which is it handles actually putting the window on the screen, handling the mouse input, playing of sounds, all that stuff we don't want to touch with a 10-foot pole, right? Image loading and all that kind of stuff that would be the entire course if we didn't use a library for doing that stuff. It uses OpenGL under the hood, and OpenGL is a bit of an older graphics library now, but it still works and it runs on a toaster. So you can actually write OpenGL code, raw OpenGL code in SFML if you want to use some more advanced features of OpenGL, but we won't be doing that in this course. And it's super easy to learn and use, as we'll find out in this course. And these are just links. So the reason I've had these slides is just so you have all these links to click on when you get the PDF. This is a link to the SFML tutorial website, which I already have open, and I'll get back to that after I talk about ImGui for a bit. because I did actually put some ImGui code in these slides. So ImGui stands for Immediate Mode GUI. We looked at that a little bit last time, but I'll have more examples here. It is really, really amazing. It's sort of like the developer's UI, right? It's not going to be what you use for like the opening title menu screen of Red Dead Redemption 3 or whatever AAA game that you happen to be working on. But it's certainly very easy to use, very powerful, and what you would use for like debugging, writing tools, simple interfaces, stuff like that. And the really cool thing about ImGui is even already maybe now, once you've seen it, you start to see it everywhere. Like, does anyone here play Rocket League? Yeah, have you ever used Backy's mod? Have you noticed the similarity between how the Backy's mod in-game menu, it's literally just ImGui, right? It's even the default color scheme. So you start to see it everywhere. And it works by directly modifying variables in memory rather than using callback functions. So if you use other UI libraries, sometimes you define a button with a function that gets called when the button is pushed, and then you have a value that gets returned on that callback function, and it's really annoying. And so here it just directly modifies variables. It works very well with game loops and the structure of those main loops that we'll be using for this course. And here's another link to some tutorials about ImGui. So it's very easy to learn and implement. Before I get into the code for that, and we'll have a full lecture on like more advanced game loop structures later on, I did want to just give a couple of slides on the way that all of our assignments are going to work throughout the term. And so the way that all game engines work, basically all programming, well, at least single-threaded programming. If you get into multi-threaded programming where there might be rendering happening over here and game logic happening over here at the same time, that's obviously more complicated. We're sticking to single-threaded for both of our sanity during this course. But basically what happens is that there is some while true going on, right? There is some loop that keeps the program running, that keeps the GUI drawing, that keeps the inputs coming. So what we're doing for this course is we have this one big while loop, and that's called the game loop, or the main loop of the program. Inside that, we have three main things that are going to be happening in this order. And the order does matter because you want, for example, you want to have the inputs from this frame before you actually do the calculations based on those inputs. And then you want to have those calculations done before you render the output of those things, right? So the order of these things does matter. So the first thing we're going to do is process user input, if any exists. So that's going to say, hey, what buttons were pushed on this frame? I might want to do something with those. Then you update the internal game simulation based on that. So the update for our assignment might be like moving the shapes around, right? So you're going to add some velocity to the position, or however you're doing that. And then once your internal game simulation is finished, then we render the current game screen, right? So we take all of whatever we've done, and the relevant parts of that calculation we're going to draw to the screen. So for example, everything is relevant to the simulation, but we may be drawing like the textures of like Super Mario to the screen, but we wouldn't be drawing like any extra debug information. All of that stuff would probably just go in the UI. And so what I would recommend, and we'll have a more formal structure for this once we get into assignment 2. So when we see assignment 2, we will actually have, so the ECS, the S stands for systems. So we will have systems that implement all of this. So we'll have an input system that will read all of the input and modify the variables based on those inputs. Then we'll have an update system, and the update system basically updates our internal game state to reflect the changes that have happened since the last frame. And then we'll have a rendering system that draws everything that we want to the screen. So we take this sort of like English description of what we've done, and then we turn that into code. And the S part essentially means that for any part of our system like this, we will have a function that implements that system. Now, the update function may be broken down into other functions. So for example, if you had an update function for assignment 1, which we don't because it's really simple, you might want to have a collisions with walls system, right? So maybe you have a movement system that updates the position based on the speed, and then you would have a collision system which checks whether or not the things are colliding with the walls. And so we'll have that when we progress on in our course. I just want to talk a little bit about some of the widgets that are included with ImGui. We will touch 0.5% maybe of what ImGui has to offer, but these are the ones that I think are important for this course, so I've put them in the slides here for you to have a nice reference. The first, and I guess other than just drawing text on the screen, which would be the simplest one, this is just a text box. So I don't see how it would be physically possible to have a text box with less code than this, right? So you're calling the namespace ImGui, say I want a checkbox, you give it the text that shows up next to the checkbox, and then you literally just give the pointer to the memory, well in this case it would be a Boolean, that you want this UI element to be able to modify. So whenever you click on this checkbox, let's say that it was initially unchecked, that would mean that this variable would be false. If you click on the checkbox, then the variable automatically gets set to true. If you click it again to uncheck it, it would be set to false. So there's no callback, so you don't need to set, okay, if this happens, then I set this equal to whatever it is. It just automatically gets that variable. The next one would be a slider. So sliders in ImGui is literally you click it and you drag it back and forth. I'm not going to tab back and forth because getting out of full screen PowerPoint is a little bit annoying. But basically, if I want to be able to change something really quickly within some range of values, then I would use a slider. And now you wouldn't want to use a slider if something could go, say, from like 0 to 1,000,000, right? Because there'd be too many like intermediary steps and you wouldn't be able to dial it in. But if you got something between like, I don't know, 0 and 100, and you've got less than 100, or you've got more than 100 pixels for the slider, then you can easily make all those values fit. So if you want a slider, you would say slider int. That would be an int slider, meaning that I would have to point to some int variable that gets that value. But if you wanted a float slider, then you could have slider float, and any other primitive data type, there should be a slider for that. Again, you would pass in the title that you want to give it. This is just the text that shows up next to it, and then your pointer to the variable there. And the cool thing about this is that whatever value that variable has when the program starts up, that is the value that will be initially displayed by ImGui. So, you know, if I had an int equal to 7, then when I start the program and I've pointed to that int, then it will initially be set to 7. And automatically, as I drag that slider back and forth, you'll see that the value of this integer variable gets changed. And the other two things that you put in is, of course, a slider has to have some sort of min and max value. So I don't know if we were going with like which day of that. I'm going to continue on with this terrible, terrible example of which day of the year is it. Like, of course you'd use a calendar, but if you wanted to be cruel and have someone actually input the integer day of the year, then you could use, you know, you'd have 1 and 365 as the, God, that was such a terrible example. All right, here's a slider float. Same thing, except that you have a floating point value that you're pointing at. And I believe, no, never mind. Next would be a slider float 2. So sometimes, especially in this course where we're dealing with 2D physics, 2D geometry, 2D rendering, a lot of our variables come in pairs. And so there would be like a speed x and y, a position x and y, I don't know, an acceleration x and y, something like that. And so built into ImGui is a slider float 2, a slider int 2. And this would just put 2 sliders on the same horizontal position. And it would label them like x and y based on what you give. So if we had a velocity that we wanted to change, then we could do this. The only slight change that you might be confused with here is that we do not pass in 2 pointers to 2 different variables. We have to pass in the pointer to an array with 2 elements. That's the way that that works, okay? And you might say, Dave, why didn't you put an ampersand in front of that? And it's because it would be redundant. Because V is like, arrays are just pointers in C and C++, raw arrays like this. And if you watch the video, you'll understand why. And so I just pass in V here, and that is the pointer to array V. And so if I modify the first slider, it will modify the first element of this array. And if I modify the second slider, it will modify the second element of that. And I'm not sure if it goes up to 3, 4, 5, like whatever the top number is, but slider float 2 is all I've ever used. The next one would be color edit, because we're doing that one in assignment 1, and you probably want this for, if you think you're making a game engine where you want to be able to edit levels and stuff, maybe the color of something is something that you want to be able to edit. So it's almost identical to slider float 2, except it's just called color edit 3, and then again you need a 3-element array that you're passing in the address of. And since it's an array, then the variable name is fine. And again, just to drive home the difference between how SFML and ImGui represent colors, the array here for colors in ImGui has to be floats between 0 and 1 to represent the RGB, whereas SFML will want integers between 0 and 255 for that. Moving along, you can also have a text box input. The only little confusing thing here, and I hate using older unsafe style C code, but that is just what ImGui uses, so we have to do that here. And in order to input text, we have to have an array of characters that we are actually inputting that text to. So as you type in that text box, you are directly modifying that array, okay? And so here we've said input text. This might be, I don't know, whatever your name is, and then you point it to a character array. We typically call those arrays where we want to put some stuff in, just a buffer. It's just some amount of space that we have available. And you also want to put in the correct size of that array. And buffer overflows are very easy to do in older programming languages, and so if we don't give it that correct, like if we gave it 1,000 here, as soon as you start typing in past character 255, which is the size of the buffer, then you would be modifying whatever happens to be in memory. It's literally like saying buffer and then 256, 257, 258, and who knows where that is in memory. Your program might crash, you might overwrite other variables, it's all unsafe behavior. So make sure that you pass in the size of the buffer correctly. I went over buttons a little last time, but I love ImGui buttons because they're so easy to make. So ImGui button, and then you give it some text. That will be the text that's drawn on the screen, right? Super simple. But that will return a Boolean of whether or not on this frame of our main loop, this button is currently being clicked or has been clicked, right? If you hold it down, that's not multiple clicks. It's just when it went from being unclicked to being in the state of clicked. That's when this event will fire. So on your mouse down I think it's mouse down instead of mouse up. I could be wrong about that though. And there may be some option here to specify whether or not you want it to happen on mouse down or mouse up. And then that will return a Boolean true, and so it will go in here, and you could say, okay, let's print out the stuff that was in the name, or let's make the character jump, or whatever you want to happen just goes in that inside those parentheses. If I wanted to have 2 elements on the same line, because by default, whenever I say ImGui button, or ImGui text, or ImGui whatever, it will just go to the next line and make the thing on the next line. But maybe I have a bunch of buttons that are really small that I can fit 5 of them on the same line. So if you want the next thing to be drawn to appear on the same line, then you can just say ImGui same line, and then the next thing that's drawn will just be to the right of that thing. And so, no, it's not like the arbitrary placement, you're not specifying the X and Y on the screen of where you want it to be, but, and I'm not going to go into like really customizing the look and feel of ImGui, because we don't need that for this course, excuse me. But this is something that you may want to do. Another thing that's very, very, very useful is tabs in ImGui. So you can have a little ImGui window. Within that, you can have a bunch of different tabs, and those are just as easy to make. So you can say, if ImGui begin tab bar, my tab bar. And you might say, well, why is this wrapped in an if statement? The if statement here basically says, is this the currently selected tab item? Right? Because if I have a bunch of different, oh no, sorry, that's begin tab bar. So this will actually make the tab and put the tab up there. And that's where that ends down here. So these things that create tabs, that create windows, they have a both beginning and an end. Okay? Down here, however, the tab begin tab item, this if statement is whether or not this is the currently selected thing. And so if this is the selected thing, then draw this stuff. right? So here we're saying if avocado is the thing that is currently selected, then draw this is the avocado tab. If instead broccoli is selected, then this is the avocado tab is no longer being drawn, right? So this is how you put stuff into different tabs, by putting it within the if statements of those tab buttons. And then for each thing that you have to end it as well. And so that will let the program know, okay, stop drawing stuff inside this tab. And when you get into more complex GUI stuff later on, if you're anything like me, you will forget these end, and then like your GUI is screwing up, and it's just basically like, I have no idea what's going on. It's probably because you forgot an end statement somewhere. All right, the next thing you might want to have is a combo box. And so by default, ImGui uses raw string arrays for combo boxes. So a string in C and C++ is just a character array, essentially. And so a const char star items, that is an array of character strings that cannot be changed. That's what this syntax means. And so I can define an array of those strings, like A, B, B, C, C, D, D. And then I need one other variable, which is the selected index. So this item index is so you have a combo box, and multiple things could be drawn in that combo box. Like here, I would have 4 things. But if I want to know which one that is actually being drawn right now, once I've selected it, it only shows one of them. And that thing is defined by the item index. So if the item index is 0, then the combo box will be displaying A. If it was 3, then it would be displaying D, 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 D. All right? And so to create a combo box, you give it a name. You give it a pointer to the current item index, then a pointer to the array of strings, and then you give it the size of that array. And instead of just saying 4 here, I can use the ImGui array size function to get the size of that array to pass it in if I want to. It's just nicer than hard coding all these magic numbers around. Yep.
You could do that with the characters as well for that previous example with the text box.
I'm pretty sure, but I don't want to say it just because I haven't tested it. Yeah. But working with hard-coded strings, this isn't much good if you are having to read in a bunch of different things from a text file, which is what we're doing for assignment 1. So you can work with vectors if you want. So the way you would do that is you create a standard vector of these items, just like you had up here, but now it's a dynamic array, it's a vector. And so what I could do is for each of my shapes, if I have all of my shapes in some container, I could push back, that's the way of adding to a vector in C++. And if I want to convert from a string into its raw C string form, and I know I hate this, is the only place you have to work with raw C strings is just because of ImGui. You can take the name string of that shape and then call C_string, and that will get you the raw string, and then you've added that to this thing. So that's how you could make a dynamically sized vector of all of these strings. Again, you would need the item index, and the only thing that changes down here is that the vector.data function, that gives you a pointer to the underlying array within that vector. So hopefully you know by 4th year that all vectors contain some internal array that is being modified, and that's how you get the pointer to that. And then you need to pass in the number of those things. Well, that's just the items.size. And the reason I'm casting this from an int here is because items.size by default is an unsigned integer, and for some reason ImGui expects a signed integer. So if you don't explicitly convert from unsigned to signed, then your compiler is going to give you a warning, as it should. Because unsigned integers have a different range of values, they can't be negative, etc. And it's just like, hey, did you really mean to do this? And so you would cast that there. One really important thing that will become much more important later on when you do the project, or assignment 4 possibly, is ImGui naming. And so let's say, for example, I wanted to have a list of textures, or a list of sprites, or a list of entities, or something like that. And I wanted to have a button next to all of them that just says delete, right? So if I do that, well, that's pretty easy to do. if ImGui button delete, delete thing 1. If ImGui button delete, delete thing 2. Like, you could all write that, that's no problem. But unfortunately, what's happening under the hood, I believe, I could be wrong, but this is essentially what's happening, is ImGui is storing its elements in some sort of map indexed by this string. So what happens is, if you create one button called delete, and when you do that, it deletes thing 1, and then you create a second one, you are overwriting the behavior of the first one because it has the same name. And so all the elements are stored by name. So you might say, okay, well that sucks. I can't have two things called this, like named the same thing with different behavior. But you can. If you add 2 pound signs or 2 number signs and then some other string, the internal string that ImGui uses to represent the data structure will change, so they'll have unique behaviors again, which is what you want. But anything after the 2 pound signs is ignored on the display, right? So even though it's called delete pound pound D1, this pound pound D1 will not show up within ImGui itself, but it will give it a unique name for its internal representation. And so then button 1 will delete the thing 1 and button 2 will delete thing 2. So just keep in mind that if you do see, hey, why when I click the first one is the last thing being deleted, it's probably because you haven't given them unique names like this. And now what I'm going to do is I'm going to quickly go to the ImGui demo website, and then I'll talk about SFML, depending on how much time I have left. Okay. So this over here is the ImGui online manual, and this is a little bit small. I can make it bigger, but it becomes like incomprehensible. So hopefully you can see this on the video. But essentially what this is, it's a listing of absolutely everything that ImGui can do. All of its settings, all of its different widgets, everything. So if you go to this link and you come over here, you can have things like configuration. So this is the actual like configuration. Do I not want ImGui to interact with the mouse? No keyboard. All sorts of different configuration options. You can come here and see them all. But what's a little better for you is, no, I'll go down here, widgets. So you'll be more interested in widgets. So for example, you might want to have something a little bit more dynamic or interesting about your combo box. So you can come down here and you can click on combo. Then you can see all these different examples of combo boxes. And when you click on this, it takes you directly to the code that implements that. So what you would do is you can click on combo box, and then this gives you all of the code down here that do all of those examples with really nice comments. So the crazy thing about ImGui is, as far as I can tell, there's no official API documentation page. This code file is all the documentation for ImGui. So you would just come over here, you'd say, oh, I want a radio button instead of a checkbox. So you'd come over here, let's see, let's just use that as an example. I'm doing it live, so it might fail, but so widgets, I'll just close this one, and now it looks like they are in alphabetical order. Let's see here. I can't even tell where combo box is. You might be able to search here somewhere. Oh, okay, let's say I want tabs. So here's basic tabs. Oh, here's advanced closing of tabs. Maybe I want to open new tabs, etc. You can do that here. So I've talked for longer than I wanted to about this, but I used ImGui for almost 6 years before I realized that this web page existed. And the funny thing is, in the ImGui code that I've given you, this code file actually exists. So in your assignment, you could say ImGui : demo, and it will launch all of this in a new window in ImGui, and so you could see it there as well. But this website is nice because you don't have to like view the thing actually in the program that's running and then hope to find it in the code. Just by clicking it over here, it will take you to that specific place in the code. There's also a table of contents up here. Oh, there you go. You can search radio. Radio button. Okay, perfect. Now it took me right there. So there's a search bar. I didn't realize that. Cool. Any quick questions about ImGui? Should be all pretty straightforward. I think you'll like using it. Lastly, what I wanted to do was go over a couple of things from the tutorial website for SFML. Oh, also, in one of the previous classes, I said that I could go overtime in this class if I wanted to because there's no class in here after us, but it turns in there's actually a class here after us. And I saw people walking in last time, so I can't go longer than I wanted to, which is good news for you guys. So all this building stuff, I've talked about that ad nauseum. I don't need to go into that. There are some interesting things that you should have a look at here in terms of like later in assignment 2, we'll be doing things like angles, like we'll be rotating some things. And SFML actually has this SF angle class. If you click here, it will go to the class reference. And you don't need to worry about converting between radians and degrees anymore because there are specific, like it's strongly, the cool thing about C++, at least modern versions, is you can put in these like strongly typed user-defined types. And so like, it won't let you convert from radians to degrees accidentally unless you actually specify that. So if I want an angle, I have to specify, is that thing in degrees or is that thing in radians? If you were doing distances, you could say centimeters versus inches. You could make conversion functions between them and all sorts of cool stuff. So I just wanted to point that out. You should give that a read because it's interesting. We're not going to be talking much about time or data streams. But I did want to go into, I talked about this a bit last time, but the SFML window. So it jumps right into the code, right? This is a bit dark, so let me see if I can turn off. Oh, that's the opposite of that. Nope. Jeez, all the things are up. Okay, that might be a little bit easier to see just for the time being. So it shows you all the code snippets for everything that you would want to do, at least at a basic level, like how to open a new window. Very, very easy. It explains in great detail all of those things, so I don't need to read this because you can go read all of those details. But one thing I did want to show is, for example, all of the different style options and stuff for window bars. And down here, I always like introducing people to this because it's not really known what this syntax is. So there are a bunch of different options for a bunch of different things in SFML. And sometimes something like a menu bar or the title bar or a certain dialog may have multiple options that you would want to hand in together at the same time. So for example, is it resizable? Is it closable? Does it have a title bar? All of these are separate options that don't conflict with each other. So you may want to be able to say, I want it to, yes, be resizable, but not have a title bar. So how would you do that? Because there's only one place for a variable for those options. So this here, I just want to show this real quick. I can turn this back on, I guess. Oh, jeez. I can't believe it's like a different button now. There we go. All right, so this is how this works. Has anyone heard of a bit set before or used a bit set? You may have heard it if you were in my previous class. Okay, that's good. Let's say we have, why is this so small? Anyway, let's say we have a character. So a character is 8 bits, which is 1 byte. And I want to be able to store options for a program inside this character. So what I can do is, let's say I make one option whether or not it's resizable. Another option, I'm going to give it a different bit, and this is what it's closable, if that's even a word. And another one might be, I don't know, renameable. And I want to be able to pass in, so if my window function has one settings variable that I can pass in, how can I pass in the values for these into a single settings variable? Well, it turns out that there's a really clever trick you can do where you can set the individual bits of these things, and it's called a bit set. So for example, if I take the OR of these things, OR on a bit set will combine those things together, right? So let's say I wanted my window to be resizable and renameable, but not closable. So I could have char settings equals, and I'll take the resizable value, resizable, and then OR it with renameable. And then what you'll get out of that, if you actually do the OR of those two things, you'll get 0, 0, 0, 1, 0, 1. right? So you take the first one, which is resizable, you OR it with renameable, and now you get this. And then if you pass this into your Windows settings, it says it is renameable because that bit of the bit set is set to 1 instead of 0. It is not closable because the bit representing closable is a 0, but it is resizable, or sorry, is renameable and resizable because those are both equal to 1. And this is a very cool way of combining a set of Boolean variables into a single variable. But the downside of this is that the maximum number of options you can have is limited by the size of the data type. So for example, I've done it here so I didn't have to type much, but if you had like, even, on most modern programming APIs or languages, you're going to have like at most like 64 bits to work with, right? So you could have 64 of these options that you could OR together, but if you have a 67th option, then you can no longer do it because you don't have 67 bits to work with or whatever. Or I don't know why 67, 65 would be the next number. So that's what that is, and that's why over here it says the default style is title bar or resize or close. So what that means is, oh Jesus, that by default, if you just open up an SFML window with no options specified, it will have a title bar, which you've given a name. It can be resized, so if you go over to the sides, you can resize it, and you can close the window. But if you wanted to, you could specify your own settings for that. So that's just to keep in mind for later. Other options, you can do full screen, floating windows, you can store the last place it was created, etc. I won't go into that. But here is where we kind of get started with our assignment. And again, I know this is a bit small. I can't remember which one I did last time. All right. So what we have in our assignment, this tutorial, I won't go into it all again, but it does go into detail on all of these options. So here, this would be the main loop for our program. Because in our program, well, if the game window gets closed, then we don't want to run the game anymore, right? Maybe you have a game where that's not true, but for our game it is. So instead of saying while true here, we just say while the window is open. And then we could do something like, hey, let's check the events that happened. And so the syntax for that is here. I'm not going to go into all the syntax because I'm about to do that for other events. There are properties of the windows that you can set dynamically. So you could set the position of the window. You could set the size of the window, the title. You can get the size. Something cool for later is you may have played some games where it has like a foreground FPS and a background FPS. So that like if you tab out of your game, the game is no longer like your main focus, so you don't want it to use as much CPU. So you could do something where you say, hey, does the window have focus? Meaning, is it the top level window on my operating system? That means I'm playing it. So if it does have focus, run it at max FPS. Maybe if it doesn't have focus, set it to 10 FPS or something like that. Other options here, I'm just scrolling through seeing the things that I want to mention to you. Vertical sync, we are going to keep vertical sync enabled. And what that does is, or VSync, as you may have heard this be called in other places, is just whether or not the game can be drawn. How do I explain it? If the game can only be drawn in lockstep with the frame rate, not the frame rate, but when your monitor actually refreshes, that is called vertical sync. If you turn vertical sync off, then you may be rendering frames of your game in the middle of when your monitor is actually refreshing, which can lead to like tearing, it's called. So if you slowly, smoothly pan around your game, you may see weird graphical effects if you don't have VSync on. Some people keep VSync off for performance reasons, but it ends up having visual bugs. Events are interesting. So this is one of the changes for SFML3 that I didn't really like, because events in SFML2 were just integers that you checked against, but they wanted to get all fancy with modern C++. And so what they do is, okay, they explain it here, but so I won't read it all, but this is essentially the syntax. Is this an event of a given type? They use templates to do this. And so down here is the example. I am going to say, okay, I'll go back a little bit and explain. One thing that you can do when programming a game, how do I get the inputs, right? Let's say that you are just given a global function, and that global function is, hey, is the B key currently being pressed? Or is the spacebar key currently being pressed? Now, that would be fine. You could make a game based on those functions, but what happens is you're really only concerned with whether or not the B key was just pressed on this frame, like it went from being unpressed to pressed, or from being pressed to unpressed, right? It's very rare that you would want to do something other than that. Now, if you're playing a game like Jump King, for example, you might want to count the number of frames that the thing has been pressed down, but still, that's just a counter that gets reset whenever you press the button, right? So, most APIs for things like SFML will give you two options. You can either know when the B key is being held down, but then in order to know if it was just pressed, you would have to keep a variable. Like, was the B key pressed on the last frame? That's your Boolean variable. And if that's false, but it's true on this frame, then you know, okay, this event was fired. So instead of doing all of that yourself, they instead have this other method of being able to do it called events. And so SFML in the background keeps track of all of this, where it's doing the polling, and it gives you basically a collection of events that you're going to iterate over. So here, const standard optional event equals window.poll event. I am not going to explain what standard optional means. Usually this is just auto. I hide that detail from you. This is a modern C++ thing that, this is why I don't like this change, because it's hard to explain what is going on. But essentially, there's some number of events. Let's say 10 buttons were pressed that frame somehow, then this event loop would go 10 times, because there's 10 different events. Then okay, we know that this is an event. What event was it? So if this event is the window being closed, meaning the X was pressed on the top right or the top left of your screen, depending on your operating system, what do I want to do when that button is pressed? Well, I want to close the window. Okay. Otherwise, maybe it wasn't that button, it was a key press event, right? So if the event getIf standard event key pressed, then this variable will now hold all the information about that key press. So if you want to know which key was pressed, you can go key pressed scan code, so that's a variable within key pressed, and since this is a pointer, for some reason, oh, I don't like this change. This is a pointer, so you have to use this syntax to get at the variable. But again, you only have to do this when you're handling event stuff, which will completely get rid of all this by assignment 3. But hey, is this the escape key? Was the escape key just pressed? That's what this says. If so, window.close. So that's how you would also close the window when the escape key is pressed. Similarly, you may want to do something when the key is released. And so there's another event type called key released. There are other events for mouse button pressed, mouse button released, mouse moved, meaning that it went from one position to another, and you'll be able to get all of that data from there. And so I won't go into any more detail, but one thing I do recommend, and I think I do this in the assignment, do I? Hang on. Yeah, but I want to see how I did this. Okay. So sometimes when your game has a bunch of different buttons that could be pressed, like you might have 10 different hotkeys in the game, instead of saying if key pressed scan code equals this, you'd use a switch statement instead. So you're all familiar with if statements versus switch statements. So because these scan codes are actually integers under the hood, you can use switch statements with them. So you can just say switch key pressed scan code, and if it's X, do this, if it's Y, do this, and it just eliminates a bunch of code. Okay. Got a few minutes left. So I won't go into keyboard, mouse, and joysticks. You're all capable of doing that now that I've done this. Using OpenGL in an SFML window, that is actually like writing raw OpenGL code, which we're not doing in this course. Drawing 2D stuff, this is pretty important. So here, for example, we have seen that this main loop has some structure. I went over that a bit in the last lecture, I believe, with main.cpp, how this works. So the main.cpp that I gave you is almost identical to this. It's just that it draws stuff here. So the important part of this main loop and this SFML code is that you handle events first, then you update the game state somehow, then you draw everything. And the drawing, just make sure it goes between window.clear and window.display. And you may be asking yourself, well, why do I need this window.display? Well, just briefly, back in the day on like the Atari, you know, these old school game programming consoles or game consoles, you had to like manually time a whole bunch of stuff that you don't have to worry about anymore. So like the way old CRT monitors used to work, there's literally a gun firing photons at this like phosphorescent screen that lights up at specific times. And so it would like draw from left to right all the way down and then hit like this bottom line that told it to go back to the top, etc. And what would happen is you could do some cool tricks to get some extra FPS out of your game by like saying, okay, that's cool. Oh, there's a button here. All right. So just like that, it went from top to bottom. I meant that, right? So like if you drew something at the wrong time before the pulses of light got there, it would like screw up your actual graphics. The way things work now is that because we have so much RAM and so much memory and everything, there's this like multiple buffer system. And so just the easiest way of visualizing this is that there are two buffers. So a double buffered system, I think maybe SFML uses double buffer behind the scenes, but essentially there are two graphical things, right? The thing we are drawing to the screen is just a bunch of pixels in a texture. So just put this texture on the screen. So there are two of those. One is the thing that is currently being displayed by the screen, and the other one is the thing that we are currently modifying with our drawing calls, right? So this thing is being drawn to the screen, right? It is on the screen. If our draw calls were actually modifying the things that were on the screen, then this wouldn't be updating nicely 60 times a second. It would just be happening like whenever those pixels were updated. What happens here is all the draw calls I made on this frame are going to this secondary buffer. And if you actually look at the cool thing about OpenGL is it actually teaches you about all this, and you have to manually make all these calls like GL swap buffers and stuff like that. So I'm drawing to one buffer, and then at the end, when the time is up for our 16 milliseconds for this frame, it literally just swaps the variables. So the thing you were just drawing to is now the thing that's being displayed, and now you have this other thing that just got cleared that you can draw to. And now you're drawing to that one, and at the end of this frame, they swap, and then they swap, and then they swap. So you are writing essentially to one buffer while another one gets displayed, and then the variables just keep swapping, and then that gets sent to the graphics card. So the window.display, under the hood, one of the things it does there is swap those buffers. Here, there are a bunch of things. I just quickly want to go over sprites. Actually, you know what? We're not doing sprites right now. I'll go over sprites when we get to sprites. Shapes. So shapes are cool. We can very easily draw different shapes of different types. So if we want a circle shape, I went over that a bit last time. Rectangle shapes, there are outlines, there are fill colors. Have a look at this if you want your circles to look cooler. You can give textures to circles if you want to. I wouldn't recommend it for assignment 1 because we're not loading textures yet. And then you just draw it with window.draw. There are rectangles, there are triangles, there are all sorts of different shapes. One of the biggest questions I get about assignment 1 is how do I store the rectangles and the shapes, right? There are so many different ways that you can do this, and I am not enforcing either one of them for this class. But one way would be sort of a quick and dirty way, if you want to, where you would have a structure. I would just call it like Dave's shape or something like that. Dave's shape would store the shape that I'm currently drawing. Maybe I have a little Boolean there to say whether or not, or an int saying whether or not it's a rectangle or a circle. Then it would store like the radius or the width and the height depending on which type of shape it is. And then I could just have a vector of Dave shapes, right? Another way you could do it, and I'm absolutely not enforcing this, but you can play around with it if you don't have any other assignments due or whatever, is that SF rectangle shape and SF circle shape both inherit, so there is a little object-oriented programming going on behind the scenes, from an SF shape object, right? So it's possible that you could store them as their base class instead of the derived class, and then you could maybe just have a vector of SF shapes. But even if you do that, you'll still have to have still have to store the velocity and stuff like that that don't have variables within the SF shape class. So any way that you want to do that, you can. Just be aware that all of these shapes do inherit from a single shape base class if you want to do it that way. And is there anything else in the assignment code that I want to go over? No, I don't think so. I think that's basically it. Like, we're doing very basic stuff for assignment 1. For future assignments, because assignment 1 kind of came out so quickly, I didn't have time to like show you this. So for this one, we kind of went, here's assignment 1, and then in the next lecture, I'll tell you how to do it. But for the future assignments, I'm going to say all the stuff you need to do before the assignment is out. So everything you need to know for assignment 2 will be given to you before assignment 2, and everything for assignment 3 will be given before assignment 3, etc.